Section 5.6 of your textbook deals with the topic of solving quadratic equations. A quadratic equation is any equation that can be written in the form ax squared plus bx plus c equals 0, in which a, b, and c are constants, and a is not equal to 0. Now the first term, ax squared, is sometimes called the quadratic term. That's because in the case of a equaling 0, this equation would reduce to a linear equation, bx plus c equals 0. So it's the presence of that ax squared term that actually makes the equation quadratic in nature. There are several different methods that can be used to solve quadratic equations. In section 5.6 of your textbook, we cover 2 of those methods, factoring and graphing, but we'll cover several other methods later in this course. In this video, we're going to focus on the first method, solving a quadratic equation by factoring. And to do this, we're first going to write the equation in standard form, ax squared plus bx plus c equals 0. Then we will factor the polynomial on the left-hand side. And finally, we'll make use of the zero product principle, which states that if ab equals 0, then a equals 0, b equals 0, or both. Put another way, if the product of 2 expressions, a and b, is 0, then one or the other of the expressions must be equal to 0. Let's look at some examples. We'll solve each equation and write the solution set. The first equation is already written in our standard form of a quadratic equation, so we'll proceed to factoring the trinomial x squared plus 4x minus 21. This trinomial is the product of 2 binomials, x plus 7 and x minus 3. Now we can think of the x plus 7 as factor A and the x minus 3 as factor B. And since the product of those 2 factors is 0, either x plus 7 must equal 0, or x minus 3 must equal 0. So we have 2 linear equations that we could solve. In the first case, the solution is negative 7. In the second case, the solution is 3. Both those numbers, then, are solutions of the original quadratic equation. And so we can write the solution set as the set containing negative 7 and 3. Let's go to a second example. Problem 2, 6y squared equals 9y. Avoid the temptation of trying to treat this like a linear equation and try to isolate a variable. We see that y squared, so we know it's a quadratic equation. So we're going to write this equation in the standard form for a quadratic equation. We can do this by subtracting 9y on both sides. Now we have 6y squared minus 9y equals 0. We want to factor the binomial on the left-hand side. There's a greatest common factor of those 2 terms, which is 3y. Using the distributive rule, we can write 3y times the quantity 2y minus 3 equals 0. In this case, our factor A is 3y, and our factor B is 2y minus 3. So using the zero product principle, we have 2 equations, either 3y equals 0 or 2y minus 3 equals 0. Solving those 2 equations, we obtain the solution 0 or the solution 3 over 2. So those are the 2 solutions of our quadratic equation, and here is our solution set. Let's move to example 3. The quantity x plus 2 times the quantity x minus 7 equals negative 18. Notice that the left-hand side is already in factored form. However, the right-hand side is not equal to 0. So unfortunately, we cannot make use of the zero product principle. We will need to rewrite the equation in standard form first, and then move from there. So first, we will multiply out the binomials. X squared minus 5x minus 14 equals negative 18. Adding 18 to both sides gives us x squared minus 5x plus 4 equals 0. Now we have a quadratic equation in standard form, so we'll factor the trinomial as the product of the 2 binomials, x minus 4 and x minus 1. We can identify our factor a as x minus 4 and our factor b as x minus 1. So there are two linear equations here that we can write, x minus 4 equals 0 and x minus 1 equals 0. The solution of the first equation is 4, and the solution of the second equation is 1. So our solution set, once again, has two numbers in it. In this case, 1 and 4 are the solutions of the quadratic equation. Finally, let's look at example 4. Once again, we've got some work to do to put this equation into standard form before we begin our factoring process. So we'll use the distributive property. And then we will eliminate the terms from the right-hand side of the equation by adding 3x to both sides and subtracting 15 from both sides. Now that our equation is in standard form, we can factor the trinomial x squared plus 10x plus 25. In this case, we have a perfect square trinomial, so this factors to the quantity x plus 5 squared. Now notice that in this case, the a and b factors are actually identical. Both factors are x plus 5. So our only option is that the factor x plus 5 equals 0, which means x equals negative 5. And this is a quadratic equation which has only one solution, and the solution is negative 5.